Hey guys, let's go ahead and add and subtract fractions with unlike denominators. Remember, the denominators are the numbers that are down below in a fraction. They tell me how many parts are in a fraction. So our steps are simple. The first is, if the fractions are different, we're going to find the least common denominator. So a common denominator, because we're going to be writing equivalent fractions so that we can add and subtract. And our final fourth step is to simplify. So let's go ahead and get started with our first problem here. 2/3 plus 1/6. So we need to find the LCD of 3 and 6, our denominators. I'm going to use the ladder method. You may have learned the list method where you list all the multiples. We can also use the ladder method where we find a common divisor for 3 and 6. 3 and 6 can both be divided by 3. And 3 divided by 3 is 1. 6 divided by 3 is 2. And then we just multiply all the numbers outside the ladder. This is an easy way. And the product of 3 times 1 times 2 is 6. So now that we know 2/3 needs to be written as an equivalent fraction with a denominator of 6. And remember, friends, we can see this visually. 2/3. This fraction model shows me thirds. I have 2 shaded in. And now I'm changing the denominator to 6. I'm actually doubling it or multiplying it by 2. And now you can see I have 6 in my fraction model. And of those 6, 4 are shaded in. And that's how we make equivalent fractions. Again, 3 times 2 is 6. 2 times 2 is 4. To make an equivalent fraction, we need to multiply the numerator and the denominator by the same number. So now that we have 4 6 here, I can easily just add the 1 6, and that will give me the answer of 5 6. No need to simplify here. Let's go ahead and our next problem, 3/4 and 2/8. Again, the least common denominator, I can think of the multiples of 4. 4 times 1 is 4. 4 times 2 is 8. So in this model, I only need to write an equivalent fraction for 3/4. How many eighths are in 3/4? Again, if you need to see it visually, go ahead and draw a model. There's my model. I have fourths. 3 are shaded in. And if I draw a line horizontal, I'll double the amount of parts, making eighths. And of those eighths, I can see there are 6 shaded in. And again, we're writing an equivalent fraction by multiplying the denominator and the numerator by 2, by doubling it. So now that I have an equivalent fraction here of 6/8, I can easily subtract 2/8. 6/8 minus 2/8 is 4/8. In this equation, I can simplify. Both 4 and 8 are divisible by 4. You need to know your facts, friends. So 4 divided by 4 is 1. 8 divided by 4 is 2. 4/8 is equal to 1/2. If you don't believe me, just draw a visual model. In our last problem here, we have 9/12 minus 1/4. Now, I know that a multiple of 4 is, you got it, 4, 8, 12. So I only need to write an equivalent fraction for 1/4. Again, if I want to draw a model, I can see that 1 out of 4 shaded in, and I can make it into into 12ths by making 3 parts here. Let's do it. Look at that. I have 3 rows of 4. 3 times 4 is 12. And of that, how many are shaded in? You got it. There's 3 shaded in. So 1/4 equals 3/12. I can prove it by multiplying 4 and 12 by the same number, which is 3. 4 times 3 is 12. 1 times 3 is 3. Now I have 3/12. I can subtract 9/12 minus 3/12. Remember our original fraction here? And 9/12 minus 3/12 is 6/12. And finally, I can simplify this fraction because 6 and 12 are both divisible. Their greatest common factor is 6. 6 divided by 6 is 1. 12 divided by 6 is 2. So I have 1/2. Let's do some more complex problems. And again, you can pause the video at any time and draw a visual model. It'll help you prove it. Okay. Again, we're going to follow the simple steps of finding the LCD, writing an equivalent fraction, adding and subtracting, and simplify. Notice that in this problem, I even have some mixed numbers. So it's going to get a little bit challenging, so just follow along. 4/5 minus 1/12. Now, I need to find an LCD, least common denominator, of 5 and 12. I know that 5 is a prime number, so the least common denominator is going to be the product of 5 and 12. Since 5 is prime, it's only divisible by 1 in itself. So 5 times 12 is 60. So it's a good little trick to look out for if you see a prime number. It'll be the product of the two. And then what we're going to do is write our equivalent fraction. So we need to think, what number times 12? Well, we just did that. 12 times 5, right, is 60. So we're just multiplying our numerator times 5. And 5 times 12 is 60. So 4 times 12 is 48. And our next step is just to subtract. Now that my fractions are the same, 48 minus 5 is 43/60. Since 43 is a prime number, it's only divisible by 1 in itself. So no need to go further to try and simplify. Okay, 5/6 minus 3/4. Let's use the ladder method here because these are both even numbers, so they might have a couple of common multiples. Let's find the least common one. 6 and 4 are both divisible by 2. Put 2 on the outside. Always a good rule of thumb, if they're even, they're divisible by 2. 6 divided by 2 is 3. 4 divided by 2 is 2. And then we're just going to multiply all the numbers outside the ladder to find the LCD. 2 times 3 times 2. 2 times 3, 6 times 2 is 12. So now we're going to write equivalent fractions with our denominator of 12. Go ahead and see if you can do this on your own. We've been practicing the skill now, so you should have it. Again, rewriting these fractions, 4 times 3 is 12, so multiplying our numerator times 3 will get me 9. 6 times 2 is 12, so 5 times 2 is 10. And since I'm subtracting, I'm just going to find the difference of 10 and 9 since my denominators are now the same. 1/12. No need to simplify. The last one is a lot of steps, so pay attention. We have a mixed number here. We have 5 and 1/3 and 2 and 7/8. The LCD, least common denominator, is going to be the product of 3 and 8, since 3 is prime. 3 times 8 is 24. So let's go ahead and write these numbers with a common denominator of 24. You could change your mixed numbers to an improper fraction, but I'm going to keep them as fractions and then I'll just go as preceded. Okay, let's go ahead and rewrite these equivalent fractions. 3 times 8 is 24, so 1 times 8 is 8. 8 times 3 is 24, so 7 times 3 is 21. Remember, we're subtracting. We need to find the difference between 21 and 8 since my denominators are now the same. But since 21 is bigger than 8, I'm going to have to do something called regrouping. I'll have to borrow from my whole number in 5 and 1/3, which I've now rewritten as 5 and 8/24. Take one whole away from the 5, leaving 4. And that one whole I'm going to add to my 8/24. So think about it. What would be one whole that I could use here for 24ths? Remember, any number with a numerator and denominator are the same is equal to one whole. Since my denominator in this case is 24, I'm just going to write 24 over 24 because that equals one whole. And now I can just add 24 plus 8 to make my numerator bigger. 24 plus 8 is 32. So now I have 32 24ths. I can take away 21 from 32. And the difference is 11 24ths. But don't forget, you still have those whole numbers to subtract too. 4 minus 2 is 2. Remember, I kept my fractions as fixed numbers. It makes them a little bit neater, otherwise you have some really big improper fractions. So that's how we add and subtract fractions with unlike denominators. I hope you liked this video. Don't forget, like, subscribe, leave a comment, and let me know what else you'd like to see.